Hello Year 9. This week's lesson is Angles in Polygons and Special Triangles. As usual, a link to this video can be found on the PowerPoint. You should also make sure that you read the checklist thoroughly and send me a copy when you've completed it. You will be doing two different types of questions. The first type of questions are to do with polygons and their properties, and the second type of questions are to do with special triangles and how to find missing angles. All the information needed is on the PowerPoint and in this video. There are answers as well, so you can mark your work. First of all, let's have a look what a polygon is. Polygons are two-dimensional shapes. They're made up of straight lines and the shape is always closed. So of these three images, the first image is a polygon because it consists of straight sides and the shape is a closed image. The second shape is not a polygon because this side is curved and polygons only consist of straight edges. And the third image is not a polygon because there is a gap. Polygon comes from the Greek word poly, meaning many, and gon, meaning angles. There are two types of polygons. Regular polygons have all sides the same size, and the interior angles will be equal. This green shape here is a regular octagon. It has 8 equal sides and 8 equal interior angles. The pink shape is an irregular polygon. It also has 8 sides, but because they are unequal, this is an irregular octagon. All the interior angles will be different sizes. To be able to know the name of a shape, you need to count the edges. You will need to copy out this table into your books so you can recognize the name of the polygons and the number of sides. A three-sided shape is a triangle. Four-sided shape is a quadrilateral. A regular quadrilateral is a square. Five-sided shapes are a pentagon. 6 are a hexagon. Seven-sided shapes have two names, more commonly known as a heptagon, but can also be called a septagon. You will need to know the name of both. 8-sided shapes are called octagons, 9 is a nonagon, and 10 is a decagon. Irregular shapes will look different depending on the lengths of the sides, so you need to count the edges to know the name of the shape. Now let's look at triangles. There are special triangles that have different names. A triangle that has 3 equal sides will also have 3 equal angles of 60 degrees, and this is called an equilateral triangle. Acute triangles will have different sides and each angle is always less than 90 degrees. An isosceles triangle is quite a common triangle that you will find in questions and is easily recognized by these two markings. The angles beneath those markings will be equal. We call this base angles on an isosceles triangle are equal. A right-angled triangle will have one angle of 90 degrees. Sometimes you get to hear about obtuse and scalene triangles, but this is less common. An obtuse triangle will have one angle greater than 90 degrees, and a scalene triangle has no equal sides and no equal angles. Things to remember are angles in a triangle always add to 180. Also, angles on a straight line add to 180, and a right angle is 90 degrees. I will show you how to use these facts in the next few questions. Here are 3 examples that will help you answer the questions from slides 4 and 5. The first example is a right-angled triangle. I can recognize it from that square, so I know this angle is 90 degrees. I've been asked to find x, so if I add 90 and 39 together, this gives me 129. And because angles in a triangle always add to 180 degrees, if I take away 129, I now know that x is 51 degrees. Sometimes you are asked to give reason for your answers. So for the next two questions, I'm also going to write down the reason for my workings out. This second triangle is isosceles, but it's turned on its side. Remember, it's the angles beneath these two dashes that are the same. So this angle here is 58 degrees because base angles on an isosceles triangle are equal. If I add those together, I get 116 degrees. Then, if I subtract 116 from 180, I know that x is 64. The reason for my answer is that angles in a triangle add to 180 degrees. So x is 64 degrees. The third example is similar, but we don't know all the angles in the isosceles triangle. What I do know is this degree, the 100 degrees here, is on a straight line. So if I subtract 100 degrees from 180, I know that one of the base angles on my isosceles triangle will be 80 degrees. The reason for this is because angles on a straight line add to 180. So the base angles are both 80 degrees, which I can add together to make 160 degrees. And then I subtract that from 180, and I know that x is 20 degrees. If you require some extra practice, you can click on these links to do the corporate maths exam type questions. This is optional, but if you require extra practice, I think it's a good idea to do it. When you've completed that work and the questions at the beginning of the PowerPoint, you can then go on to the MathsWatch questions. The final 4 questions are pretty tricky, so I'm going to talk you through the answers for those questions now. This is question 13. You are asked to find this angle here, called x, and to give reasons for your answer. Now what I can see here is a triangle with 3 equal markings. So this is an equilateral triangle, and the angles will all be 60 degrees. I then need to recognise another angle. These lines here are parallel, so I'm looking at an alternate angle that we've looked at previously in class. Alternate angles make a Z shape, and the angles within those Zs are equal, so x will also be 60 degrees. The reason is alternate angles are equal, so x is 60 degrees. Question 14 of your homework. You've been asked to find out what type of triangle this is. Now you might think it's a scaling because all angles are different, but we don't know this. So what we've got to do is work out the missing angles. There's not a lot to go on inside the triangle, so I'm going to look and see if I can find another alternate angle. I can see a Z shape here, which means that the angle here at A is also 50 degrees because alternate angles are equal. If I then add 50 and 80 together, I'm looking at angles inside a triangle. I can see that those two angles equal 130 degrees. So by taking that away from 180, I can see that the other angle at the bottom is 50. This means that this must be an isosceles triangle because the two angles at the bottom are the same. Base angles on an isosceles triangle are equal, so the type of triangle is an isosceles. Question 15 on the MathsWatch is quite tricky. So this is what I'm going to do. I'm going to talk you through using the information given. We're told that ABC, so ABC is the big triangle here, is isosceles with line BA, which is here, being equal to line BC, which is here. D lies on AC. The reason we're told this is to know that ADC is one straight line. ABD, which is this smaller triangle here, is also isosceles, with AB being equal to AD. We've been told, and we can see in the diagram, that the angle ABD is 72 degrees. Now how they've labelled that is, if we go from letter A to B to D, we've created this angle here. It's worth remembering how to label angles. You've been asked to show that BCD, which is this smaller triangle at the end, is isosceles. So we need to prove it and show each stage of the working. So, because I know that the first triangle at the end, ABD, is isosceles, I know that the two base angles will be equal. So I can say that BDA is equal to ABD, which is 72 degrees. I can then use that by adding those together and taking them away from 180, and that leaves me with 36 degrees, because angles in a triangle add to 180 degrees. This is helpful because right at the beginning we were told that triangle ABC was isosceles, so I'll be able to use that over here. I can also find this missing angle because 72 and this angle here are on a straight line, and straight lines add to 180. So I know that this angle is 108, and I know that this angle here is 36 because angles in an isosceles triangle are equal. Therefore, I can now find this top angle by adding those together and taking away from 180. This will give me 36 degrees. When I put that on my diagram, I can see that I have two angles that are the same. So therefore, this triangle is isosceles. There's quite a few steps to go on here, so you may want to write all this information down before you attempt your homework. The final question of the Maths Watch doesn't give you any angles, but you're told that the shapes are equal. For instance, ABCD is a square, and squares have 4 angles of 90 degrees. We're also told that triangle DEF is equilateral, and so therefore all these angles are 60 degrees. I'm going to just write down this information and use that to find the missing angles for the triangle ADE. I can see that this angle here 90 and this angle here 60 forms part of a straight line. So if I add them together and take them away from 180, it leaves me with one of the base angles on the isosceles triangle being 30 degrees. Because it's isosceles, I can then label the other angle also 30. The question is asking you to find angle AEF. So if I start at the letter A and go to E and then to F, I can see I've created this angle here, which is 30 plus 60, which is 90 degrees. The diagram is obviously not drawn accurately, so this angle is 90-degree angle. Thank you for taking time to look through the lesson and the PowerPoint and listening to the video. If you need any extra help, please contact me. Thank you.